Hi everyone, myself Dr. Lakshmi Prasad, working as a professor in CRC in Institute of Aeronautical Engineering, Hyderabad. In this video, I'm going to discuss about what are the various algorithms that are available for the construction of MST, that is nothing but minimum spanning trees. So, what is a minimum spanning tree here? So, a spanning tree is nothing but the connected graph where the vertex should be same as the vertex of the given graph, and whose wedge set is also should be a subset of the edge set of the given graph. Suppose if I'm going to have a graph like this, if I'm going to have a graph like this, so this one I'm going to be considered as vertex set, and weight of the spanning tree is nothing but the sum of the weights of all the edges in the tree. And minimum spanning tree is a spanning tree with the smallest possible weight. Okay, so the weight of the spanning tree is nothing but the sum of the weights of all the edges in the tree. And minimum spanning tree is the spanning tree, so with the smallest possible weight. Suppose if I'm going to have a graph like this, so these are the minimum possible spanning trees of the given graph. So this is one of the possible of the given graph, and this is also another possible of the given graph, and this one is also another possible of the given graph. Next one, if I'm going to have the weights like this, okay, so I have to find the spanning tree in such a way that the sum of the weights of the given graph should be minimum. Okay, so then only I can able to say this should be the minimum spanning tree, minimum weight spanning tree. So the minimum spanning tree of the graph is going to be obtained, which where the sum of the all the weights should be the minimum one. So how are we going to construct this weighted minimum spanning tree, minimum weight spanning tree? So what is the logic I'm going to obtain? So for this I'm going to have two types of algorithms. Like first one is Kruskal's algorithm, and second one is Prim's algorithm. So what is this Kruskal's and Prim's algorithm here? So both algorithms are going to be different methodology. So but eventually end up with the same spanning tree. So whatever the spanning tree I'm going to construct through the Kruskal's algorithm, so that should be the same. And so what is the algorithm that I'm going to construct, that also be the same here. So in this algorithm, so at any instant of output, it represents the tree, whereas in Kruskal's algorithm, at any instant of output may be represent the tree or not. So these are the two algorithms that are going to be available for the construction of spanning tree. So the Kruskal's algorithm is going to be used the edges, whereas the Prim's algorithm is going to be used the vertex connections in determining the minimum spanning tree. Okay, so the Kruskal's algorithm going to be used the edges here, and the Prim's algorithm going to be used the vertex connection in determining the minimum spanning tree. So in Prim's algorithm, at any instant of output, is going to represent the tree, whereas in Kruskal's algorithm, at any instance of output, it may represent a tree or not. Kruskal's algorithm. So this should be the greedy algorithm, and here a greedy algorithm able to choose some local optimum. Okay, so the greedy algorithm, Kruskal's is nothing but a greedy algorithm. So which is going to be choose only the local minimum, and how are going to work this Kruskal's algorithm here. So for this, eventually how to take a graph with n vertices and keep on adding the shortest least edge while avoiding this creation of cycles until the n minus 1 edges is going to be added here. So sometimes the two or more edges may have the same cost, and the order in which the edges are going to be chosen, so in this way doesn't matter. So the different minimum spanning tree may result that that they will have the same local cost which always be the minimum cost here. Okay. Uh, so the how this critical algorithm is working. So initially I'm going to have a graph. So V1, V2, V3, and then V4. So among this, we have to choose the minimum weight first. Okay. So while selecting this edge, so it should not be formed the cycle here. So sometimes the two and more edges is also going to have the same cost, right? So at that time, we can able to select those edges also. So the order in which the edges is not chosen doesn't matter. So but the resultant should be the minimum one. And how long that means that the sum of the weight of all the minimum span entry should be minimum. So this should be the algorithm what I'm going to be suggested here. So first make the tree as empty here and then repeat the steps 3, 4, 5 as long as the t contain n minus 1 edges and e is not empty otherwise. And then proceed to step 6. So if the t contains fewer than n minus 1, then print the spanning tree. Okay. So for this, before that what I'm going to do, so we have to be choose an edge from A of the lowest cost here and then delete this from the edge set. So if the edges does not form the cycle in the tree, then add the tree to the tree, add the edges to the tree, otherwise you can able to discard it. So okay, so first make the tree as empty here and then repeat the steps 3, 4, 5 until the tree contain n minus 1 edges. So what are the steps of 3, 4, 5 here? So choose the edge V comma W from E of the lowest cost. So then delete from E. So if the edge does not create the cycle, then add to T. Otherwise, we have to be discarded. So if the T contains fewer than n minus 1 edges, then bring no spanning tree. So I'm going to consider one of the examples. So this is the networking problem here. So here what I'm going to say, so the vertex is going to represent 8 regional data centers, so which is need to be connected with high-speed data lines. And feasibility studies shows that the link is going to be installed wherever possible, and the cost in millions of dollars, in have to be shown in the next to the link. So which link should be constructed to enable the fully communication and keep this total cost minimal. So the problem is that the vertices is going to represent 8 regional data centers which is need to be connected with high-speed data line. And this feasibility study is going to show the links which is going to be illustrated as possible, which is going to represent the cost in millions here. So the links is going to be form a spanning tree here. So how it is going to be done? So if I'm going to consider this greedy algorithm like this by considering the least edge weight among the graph, I'm going to get the cost of this cable is 427. Okay, so this links is going to be random. I'm going to choose this edges, and what I'm going to get, I'm going to get this as 427 as the cost of this cabling. So how can able to establish the minimum weight spanning tree here? So for this, I'm going to apply this principal algorithm. So how can able to do this in this algorithm? So first we have to be sort the edges by 8 and then have to build the spanning tree by adding the edge of the minimum weight which when added to those already chosen and does not form the cycle. So okay, now sort the edges by weight here. So what are the graphs I'm going to have? So consider a graph. So first I have to sort the edges. So edge and then cost. Edge AP 1, BD2, AD2, AC3 and CD3. So this is the table what I'm going to fill here. I'm going to sort all the edges. So once I sort it, I'm going to fill. So what is the first one? So AB. So usually I have to take the tree as empty, right? So what is the first one? AB. So AB I'm going to fill 1, and BD and then AD. So if I'm going to fill this AD, so it is going to form the cycle. So that's why I does not consider this edge. Next one AC. So AC is 3. Okay, it does not form the cycle. Next one CD. So if I'm going to consider this again, it will form the cycle. So that's why it does not form the cycle. I does not consider this edge also. So what is going to happen? So this should be the resultant spanning tree of the given graph. So what is the edge set here? So 1 plus 2 plus 3, that should be 6. So like this algorithm is going to work. Okay, build the spanning forest by adding the minimum weight which can be added already those two chosen, one which does not form the cycle. So by taking this application, the problem what they given, so among this problem, so it is among this, so what is the minimum weight here? That should be 23. So 23 is going to be chosen first. That should be first step one. And step two is after 23, what is the next minimum weight in this one? 29. So that should be 48. And the next minimum, what I'm going to consider, what is the next minimum weight? That should be 31. So that should be the step three. And next minimum 32. So 32 does not form the cycle. So that's why I'm going to choose this as the fourth step. And after 32, so what is the next minimum? 47. So 47 is going to be chosen. And the next one 54. Okay. So if I'm going to consider what is the next one, 74. So 74 is going to form the cycle. So it does not form it. And what is the next 75 is also going to be form the cycle. And then 80 is also going to form the cycle. So I'm not going to consider all this one. And then here also I'm going to consider should not be considered this one. And 74, even though 68 is there. So it does not form, it is going to form the cycle. So like this, we are going to construct this. So why avoiding cycle matters? So up to this point have to be taken simply taking the edges in order of weight, but now we have to be reject an edge since it is going to form the cycle. So 55 I'm going to consider. So it is going to form the cycle. So what I'm going to do, so by considering this, so what will happen here, by taking all the edges, what I'm going to mark, the sum of all the minimum weight edges is going to be add up, and then what is the finally I'm going to get 282 is the cost. But initially what I'm going to get as 427 as the randomly if I'm going to select this cost. So I'm going to 427, I'm going that should be the cost. So by using this algorithm, so how much I'm going to getting? So I'm going to get only 220, 282. So this should be better. So similarly, next one, what is the other algorithm I'm going to have is that Prim's algorithm. So Prim's algorithm is a famous and greedy algorithm, and it one is going to be used for finding the minimum spanning tree of the given graph. To apply this Prim's algorithm, the given graph must be weighted, connected, and undirected. And in spanning tree algorithm, so any cost in the tree but connected to an edge can be added. So to find the minimum cost spanning tree, so we must be selective and we must always add a new vertex for which the cost of new edge is as small as possible. And this simple modified algorithm of the spanning tree is called Prim's algorithm for finding and minimum cost spanning tree. Okay, so the Prim's algorithm is a famous greedy algorithm and is also going to be used for finding the minimum spanning tree. And to apply this Prim's algorithm, the given graph must be weighted, connected, and directed. So in the spanning tree algorithm, any vertex not in the tree but connected to by an edge can be added. This simple modified algorithm, what can able to called as a Prim's algorithm. So how are we going to do this one here? So first we have to take a tree. So one vertex only one at a time. and we have to be start with the trivial one point of the tree, and then add the edge of the minimum weight among those with one endpoint in the tree and other node in the tree. So first one is Prim's algorithm. So Prim's algorithm, how it will work. So randomly choose any vertex, and the vertex connecting the edge having the least weight is usually selected. And step 2, find all the edges that connect the tree to the new vertices, and find the least weight edge among those edges and include it in the existing tree. If including that edge creates the cycle, then reject the edge and look for the next least edge weightage. So keep repeating step 2 until the vertices are going to be included in minimum spanning tree is going to be obtained. So first randomly have to choose the vertex, and vertex connecting the edge having the least weight is usually selected. Okay, and step 2, find all the edges that connect the tree to new vertices and find the least weight edge among those edges that is going to be included in the existing tree. If including the edge is going to create the cycle, then reject the edge. And step 3, so keep repeating the step 2 until the vertices are going to be included. Okay, so this is the initial step of the Prim's algorithm. So initially I'm going to select this 47 first. So from this here I'm going to connect what is the next minimum I'm going to consider among this 23 and 75. So 23 is minimum, so that's why I'm going to select 23 first. So from here, so what is the next minimum weight? So 80 is there, 32 is there, and 93 is there. Among these three, so what is the minimum one? That should be 32. So 32 is going to be selected. So from here, so what is the next minimum I'm going to select? So I'm going to have 31, 55, 74, and 79. So among these four, so what is the minimum one? 31. So 31 is going to be selected. After that, so from here onwards, so what is the max minimum? So 74, 88, 29 is there. So out of these three, what is the minimum one? 29. So 29 is going to be selected. So from here, I'm going to select 29, 79, and 68 is there. So among this, I can able to select. It is going to be from the cycle. And again, if I'm going to select the 68, it is also going to be from the cycle. So after that 68, so what is the next minimum? That should be 66. So 66 is going to be considered. So by making this all, what I'm going to sum out the weights of all the vertices, what I'm going to get, that should be 282. So according to the Kruskal's algorithm also I'm going to get the same cost, and then according to Prim's also I'm going to get the same cost. But randomly I'm going to get 487 is getting, but according to Prim's and Kruskal's I'm going to get only 282. So that's why it should be the best algorithm. Okay, so for implementing this, so minimum weight spanning tree, so I'm going to have two kinds of algorithms. So first one is Kruskal's one, and second one is Prim's algorithm. So in Prim's, according to the Prim's Kruskal's algorithm, it's going to be different methodology, but at the same output what I'm going to get it out. So Kruskal's algorithm is going to be use the edges, whereas the Prim's algorithm is going to be use the vertex connections. So in Prim's algorithm, so at any instant of output is going to represent the tree, whereas in Kruskal's also at any instant of output it may represent the tree or not. So how the Kruskal's algorithm is working? So for giving a graph, for a given graph, so among the n vertices, we have to be choose the least weight first, and keep on adding this least weight edges until I'm going to get n minus 1 edges. So make the tree empty and then repeat the steps 3, 4, 5, and you can randomly choose it and have to delete from the edge if it is going to be from the cycle and add it. Otherwise, you are unable to discard it. So this is the problem initially I'm going to get. So initially I'm going to get 427 by simply randomly picking the vertices. So if I'm going to apply this Kruskal's algorithm by considering the graph and sorting the edges in ascending order and then filling the wedges into the graph, what I'm going to get, I'm going to get the minimum cost weighted spanning tree. So if I'm going to apply the same technique here in the given graph, in the given example, what I'm going to get, so this should be the resultant minimum spanning tree. So finally I'm going to get 282. That should be the final step of the Kruskal's algorithm. So what is the Prim's algorithm? So Prim's algorithm is also going to follow the greedy algorithm. So mainly this one is going to be used when the graph weight should be minimum weight connected and undirected only. Then only this algorithm is going to be working. So in a spanning tree algorithm, any vertex not in the tree but connected to an edge can be added one. So what are the steps in this Prim's algorithm? So the Prim's algorithm is also going to be build a tree one vertex at a time, and then we can able to start with the trivial 1.2. So what is the algorithm first step? So randomly choose any vertex that is going to be least one. Find all the edges that are connected to the new vertex. So find the least weight edge among the edges and include in the existing tree. If including the edges creates the cycle, then reject that edge. So keep repeating step 0.2 until the vertices are going to be included and minimum spanning tree is going to be obtained. So if I'm going to be impose the same algorithm in the given example, so initially I'm going to choose the one vertex, and then from I'm going to find the minimum weight, minimum age, and from here onward, what is the next minimum weight age? I'm going to find it out, and from that place I'm going to find what is the next minimum. Like this, I'm going to just find it out. So finally, if I'm going to add up of all the edges, I'm going to get 280. So that should be the resultant vertex, right? So that should be about minimum spanning tree. Uh, that should be the implementation of minimum spanning tree. Okay, thank you.
Like, share, and subscribe. Hit the bell icon for more updates.